optimizing server-side code in most of the cases. So I'll show you how you can tell if that is your problem, but for most of us, that's not our problem. So we're going to actually focus on these 3 key rules. So the first one is we want to make fewer HTTP requests. So I put it in italics because we're going to talk about how HTTP 2 changes this rule slightly, but obviously I don't want to download things that I don't have to. I want to send as little as possible. So we'll see a lot of techniques that are going to try to reduce the size of things I'm going to send. And I want to send it as infrequently as possible. So we're going to focus on these 3 things throughout the talk with various techniques. I'll mention Fiddler because I'm going to use this. So Fiddler is a tracing tool that was built specifically for HTTP and HTTPS. And so Eric Lawrence was working at Microsoft. He worked on the clip art team. People would order clip art. They would try to download it. It didn't work. They would call in for support, and there really wasn't a great tool. There was Netmon, Wireshark, Similarity today, but there wasn't something easy for people to be able to see a full request and response. So Eric didn't know HTTP, he didn't know C#, and he didn't know .NET, and he just learned all those things and wrote Fiddler, which is kind of cool. So we'll take a look at what that looks like. Again, it's free. The exciting thing today is it's always run on Windows, but there's a Fiddler Everywhere version that is cross-platform, so it also runs on Mac and Linux. So I'm going to show you Classic today. So I'm going to open up Fiddler. And I've got a fictitious travel site here that we're going to use throughout the talk. So it just is, I'm not a designer, so I got Bootstrap. So it just cycles through some various locations. And I've been to Australia a few times, so that happens to be all the photos in here. But I've got a before and after version of the exact same page. So one of the things I like to do in Fiddler at the beginning is take a look at the statistics tab. So I can see for that single web page, it was about 12 requests and it was about 3 meg. So the average web page today is probably 75 to 100 requests and anywhere from about 2 to 3 meg. So this is a pretty typical web page today. We'll take a look at the after version of this. And what you'll notice is it should look visually the same. So there's no real impact here for the performance techniques we did from a quality standpoint. But we'll see if we go back into Fiddler, we'll look at that same set of requests. So I have 13 requests, but I'm down to 187K. So we went from about 3 meg down to about 190K, which if you look back at some of the sizes, jQuery and some of the images. So there were single images before that were larger than now what the entire web page is. So that's the motivation for some of the techniques we're going to see, and I'm going to use Fiddler throughout. So I just wanted you to see how that tool works. We'll talk briefly about metrics. So there are a lot of metrics for web performance. The first one is called first byte. So first byte would be the time it takes for the browser to send the request to the server and get back the first byte of the response. So I put this in italics. It's a good IT measure. So I'll use this. We were talking about server-side time. If the first byte happens to be really slow, then you may actually have a server-side problem. So for instance, if it takes 2 seconds to get the first byte, then I will focus on server-side code. But like we said, most websites, that's not the core problem. I use speed index. So this came out a few years ago from webpagetest.org. And the idea with speed index is it will be a measure in milliseconds for how long it takes for they call it the above the fold. So what's in the viewport for, in my case, the desktop, how long does it take before that is almost all complete? And I like to use that because it's a much better measure for my customer's experience on my website. There's also time to interactive, so that tells how long it will be before all of the JavaScript stuff runs and you're actually able to interact with the page. There's also on load for how long it takes the page to actually load. Fully loaded would be how long it takes to get all the images, JavaScript, CSS, etc. Recently, Google came out with Web Vitals, so it's really a combination of 3 different things. how long it took to paint the main content on the page, how long before the first input is ready. And then lastly, and interesting, is the cumulative layout shift. So if you've been to web pages that constantly move around as they're rendering, we want to reduce that. That's not a great experience. So you may want to look at that as a good measure. It's starting to get added to a lot of performance tools. Like I said, I use speed index. There's lots of different choices, but it's important that you have a good measure. So as you use new techniques, you can see that you're actually making some improvements. How do you measure? So I talked about webpagetest.org. So let's take a look at what that looks like. So the nice thing about this, it's free. And I can come out and I can pick locations all around the world and various types of devices. So I can enter a URL here and I can tell it to capture the video. And when I punch that in, it's going to use the agent at that location with that browser, and it's going to give me a feeling for how the page is working. So if we take a look at, I hosted the before version of the site in Azure. And you notice a few things right from the very start. It gives me some grades on how first byte speed wasn't too bad, whether I keep alive, whether I'm compressing some images. And here are some of the measures that we talked about. So the one that I focus on is this. It took about 5.5 seconds for this particular browser in that location to have the speed index, which is basically that the page is visible. And again, there's a lot of other measures here. We talked about the web vitals. I like to focus on things like the waterfall. So if we open up a waterfall diagram, if you've seen this before, you can see here's the HTML request that was made, how long the DNS took, etc. Then JavaScript files. And then I can start to notice a few things. Here you can see that the images I have being requested are taking quite a long time. So I'm at about 1.5, 1.75 seconds when my images started to download. And you can see that some of those are taking as long as 7 seconds to be able to be downloaded. So right away, I can get some good feedback that I know images are one area that I'm going to spend some time on. The other thing I like about Web Page Test, it does record videos. So I find that when I'm talking to our marketing group and others, and I say, you know, we have an issue with these images being too large, it's nice to show them a visual because I can tell them how long things take. But when they get to see that, so they can see, okay, it really takes about 5.7 seconds. That's too long. If I were to go look at the same thing with the after version, I can see my grades have improved. I'm at about 1 second. If I look at the waterfall again, I can see that we've made some improvements. It's about the same time to get through all the connections, but you can see that all my images are downloading here and they're all completing in well less than a second. And if I show the video again, we can see that's a much better experience. You didn't see the slow paint. It took about a second and the whole page appeared. I like to use web page tests because it keeps these stats for a really long time. And so I'm able to keep these historically. So I do a before and after when I'm doing web performance work, just so I can see and keep a history and show people that back on this date, I did this improvement. You can see the before and the after video. It's just a nice historical for the improvements that we've made. I showed you Fiddler. I use that for a lot of ad hoc things. So when people ask me, take a look at my site, I'll run web page test. I'll also use Fiddler because I can look for a lot of particular things to see, are you using compression? Are you using expiration? Some of the techniques that we're talking about. There's also some other ways to measure. One is called synthetic monitoring. So we've been using a service for about 15 years. They hit our homepage every 15 minutes from locations throughout the United States, and they measure how long that takes. And that's called lab data. And I like that because every time these tests run, they're from the same computers on the same connection, and they run consistently. So I can see a good history of, is my site behaving poorly today? I can look at all the graphs for that, so that's useful. One thing that I'm working on right now is implementing RUM. And what that is browsers have added in these two sets of timings. So they measure today how long it takes to get your page and all of your resources. So RUM lets me tap in and see every customer on my website, how long did everything take? So I can drill into an individual customer and find out how long did the web page take? Was it slow because of their connection? Was it slow because a JavaScript file took a long time? So that's a nice thing to be able to have for your website. It's important to know when your performance is good enough. You need to think about your goals. So Amazon and Walmart both decided they would slow their website intentionally by 100 milliseconds. And they did an A/B test. They left one group alone. They slowed the other by 100 milliseconds. Coincidentally, they both lost about 1% of sales. So when you think about your website and how important performance is, 1/10 of a second might cost you 1% of your sales. So it's important to know and do some kind of testing like that and measurement to see how sensitive is your site to web performance. That will help you. I find it hard sometimes to sell performance things at work. If I'm able to quantify and get a measure for what the impact is for my customers, then I could come back and say, here's a technique that will cut our time by maybe 500 milliseconds, and I can equate that to how much more money we're likely to make. That helps pay off whatever performance technique I'm talking about. There are a couple places where you can compare to competitors as well. So if I go out to speed test, this happens to be a RUM vendor. So it's interesting to come out and just look on a slow connection with retail sites. This is how long Amazon takes to paint. So it's just nice to come out here, especially within my own company, and be able to show them how we compare to other major retailers, just to give them a feel for where we sit for performance. Another useful measure is Chrome has telemetry built in. And so anyone who's using Chrome is actually reporting back all of the timing information we talked about. So think of it as RUM for Chrome users that I can tap into. So I can come and punch in a domain here. If it's a site that's used by a lot of people, Chrome will have it and it will be able to tell me month to month, how is my performance? How do I compare to other people on mobile? And am I getting better or worse? So it's nice to use as an objective measure to show people within my company that we're making improvements or we're not. So with that, let's jump into some of the techniques. So the first one we'll talk about is compression. So I tried to order the techniques with things that are typically easy wins, not hard to set up. Again, I recommend that you try these and test these things yourself, but I did rank them by virtually everyone I've ever seen is getting the benefits kind of top down. So the first easy one is HTTP compression. So what a browser does when it connects to your server, it sends an accept encoding. That's telling the server that it can handle compressed content. So we implemented this probably 15 years or so. As soon as we turned this on, the next day we cut our bandwidth usage in more than half. So we were hosting in rural Minnesota. We were running out of bandwidth, so it was nice. We use IIS. I'm an ASP.NET developer. So we went into IIS and said we want to use compression for all of our static pages and also for all of our dynamic ASP.NET pages. Not only did we cut our bandwidth usage in more than half, the synthetic measurements I talked about got 25% faster. So it was an easy win. The only negative I've ever heard with compression, they've done a lot of measurements with research. It uses maybe 1% of your CPU or so. And so some people, when it first came out, argued that, I can't afford to have the CPU impact. I guess my opinion, if you're within 1% of CPU on your web servers of having problems, you've got other problems, right? But try this measure. It's simple to set up regardless of what server you use. So it's an easy performance win. The next one is content expirations. So the idea is if you come to my website, you're going to get my ASP.NET page. I'm going to send you the HTML. You're going to get all of my JavaScript, my CSS, and all of my images. If you were to come back tomorrow, the ideal for me would be I want you to come back and ask for the ASP.NET page because something might have changed server side. I might have had to change my JavaScript or some images. So I want you to make that first request. However, once that request is done, if I haven't changed anything, I want it to pull all of those files out of your browser cache. So for instance, if you were to visit my site today, I'm in Minnesota in the United States. That first connection may take a long time. Once you have all of that stuff in your browser cache, that's better for both of us. You're not going to use my bandwidth. You're not going to use my server resources. So I want to turn this on. So again, it's different by web server. But I will actually go into, in my case, IIS. I put all my CSS files in a given folder, all my JavaScript in a different folder. You can just set the folder and say how long you want that content to be considered fresh by the browser. So for me, I say I want my JavaScript and CSS to be kept for a year, and I keep all of my images for about 30 days. So what happens, you say, if you change an image? So if you came yesterday, you got my logo, and now you come back, and in the meantime, I've changed my logo. I'd love for you to see my updated logo. All I need to do is change my URL. So if it used to be called logo.svg, I'll just change the name to logo1.svg. Or in the case of my product images, I add a hash to the end of each one. That will force you, when you come back, you get the ASP.NET page, it's going to see this different name for the file. It won't find that file in your browser cache, so that file will come back and be downloaded again. So you get the best of both worlds. I'm using your browser cache as much as possible and avoiding all those delays and being super fast off your own machine. But in the case where I do change files and need you to get them, you're able to actually download those. And you can tell that if we go back into Fiddler, this column called caching, you'll notice on the before site, I'm not doing any, and on the after site, you can see this. If you don't set that, what you're doing is you're leaving it up to the browser to decide. So they use heuristics and decide for themselves whether they have to come back and ask for the file. And unfortunately, as I listed on the slide, a lot of times it'll be sitting there. They don't know if it's fresh. They'll come back to the server. Just talking to the server to find out if the file is fresh is also expensive. So that's what we're trying to avoid. The next one is a content delivery network. So I find it interesting how things work. Internet's been around for a while. Literally, two people, I think, from Google were in a bar, and they were having a debate about what matters more, bandwidth or latency. Every time you go to an ISP, they're constantly telling you how much bandwidth they have that you can have for your service. So they decided to run a test and see if they changed the bandwidth and measured compared to if they had less latency, which one was better. And it turns out bandwidth really doesn't matter that much. The first couple megabits per second matter for most websites. After that, it really doesn't have nearly as much impact as latency has. And what latency is, for instance, with you in Australia, coming across to connect to my data center in Minnesota, the Earth's a certain distance, right? We have the speed of light, but it still takes some time to traffic that. The latency is how long it takes your browser to get to my server and get that first response back. So because latency has a much larger impact for most websites, what a CDN does is they have servers all over the world closer to my customers than my data center. So they're pretty cheap today. There's a lot of competition. So what you do is you set up a contract with a content delivery network, and I'll show you how I will code differently, but I put all of my images, CSS, JavaScript. I have my fonts on that. I'll talk about that at some point as far as opening more connections, but I've traditionally hosted all my images, CSS, JavaScript on the CDN. So if I show you what that looks like in code, traditionally, if I were to reference an image, I would be referencing it with a relative link like this. In the case of a CDN, the CDN will give me a new subdomain to use. I use what's called protocol-less URLs. So what this does is I don't have to say HTTP or HTTPS. It will actually use whatever my page is using. So my site today is fully HTTPS, but there was a time where I had a mixture. Using protocol-less has worked for us for years, and it just lets you not have to specify. But by referencing it like this, what happens is when your browser goes to do the DNS resolution, the CDN service will actually find the server for the CDN that's closest to your location and give you back that IP address. So if one of you hit my website today, it's going to find a CDN. Hopefully there's a server in Melbourne or at least in Australia. It'll give you back that IP address. If somebody else has already been to my site, the flag small.jpeg will likely be hosted on that CDN server, and it follows all the same expiration rules as what I had set up for you as a customer. So hopefully when you visit my site, you'll travel all the way to Minnesota to get the ASP.NET HTML, but all of the other stuff will be served locally from you, which will be a lot faster. So again, that's the advantage of using a CDN. We'll talk about bundling and minification. So the idea with minification, if you've seen it before, I want to minify my CSS and my JavaScript. So what that does is it takes out all the white space and the comments and such. So let's look at what that would look like if you haven't seen that. We'll look at the performance after. So I have the Bootstrap JavaScript file. So here you can see I'm using the minified version. And if you haven't seen what minification looks like before, it looks like this, right? All of the spacing is gone. So that's great for production. There is a way to unminify, if that's a word. When I go into DevTools, I can actually say pretty print, and it will get back to something that looks like the original source. Or if I use source maps, it would show me the original source. But from a performance standpoint, most of my customers are never going to look at this and don't care. So if I use the minified, you can see it's about 59K. If we look at the performance before, you'll see that Bootstrap was about 134K. So we went from 134K down to about 60K. So cut it in more than half just by using the minified files. So I always use minified files on all of my stage and production servers. I will mention that years ago, again, we were running out of bandwidth, so we looked into bundling. And what bundling let me do is I can actually say, I want to take all of my CSS, for instance, and bundle it into a single file. So why did I do that? Well, in the HTTP 1.1 days, browsers would open up 6 connections per host. That's all that they could do. So if I had, say, 36 images on a page, it would go get the first 6, then it would wait to get the next 6, then et cetera, et cetera. By bundling all of my CSS into a single CSS file, it can use that one connection and download that CSS all at one time. I put this in italics. Currently, I use HTTP 2, so I'm about to unbundle. We'll talk about why that matters in HTTP 2, but the important thing is you should always minify. Even when you're compressing, it'll make a big difference to the size for the downloads. When we did this using free tools during our build process, our homepage was about 46% faster. So again, it took me maybe 6 hours to set all this up in my build process, and my homepage is that much faster for all my customers. So certainly still minify. Again, bundling depends on your version of HTTP. We'll talk about some images. So years ago, before there were web fonts, our designers would want text in a certain font, and they would actually create an image of that text with that font. We also used to use images for gradients. Now that those things are built into CSS3, we have web fonts, we have gradients. Try to avoid images if you don't need to use them. If there's a way to do them in CSS3, it'll be much lighter. The other important thing for images is make sure you're using the proper types. So if I'm using a logo, I want to use SVG. It scales for responsive, which we'll talk about in a minute. If I'm using photos, I want to use JPEGs. And so I get in debates sometimes with people that say, well, PNGs can do photos, why don't you do that? So what I always say is try it out for yourself. So in Sydney, I did the bridge walk, very cool. I took my dad. I found out he was afraid of heights that day, so I probably should have asked before, but we had a good time. So if you take a look at this image, this is a JPEG. If you look, here's the PNG. They look visually the same, but if you look at the sizes, the JPEG's about 60K and the PNG is about 516K. So I'm going to show you how JPEGs can be compressed, and that's why you should use JPEGs, because you're able to do compression and trade off some quality for size. So again, if you don't believe that, test it out, right? There's also some newer formats like WebP, etc., that have come out. I haven't used those yet. They're a little more complicated because you don't have all of the browser support. So if we go look, I don't know if you've seen this site before, but Can I Use? So there's a brand new format called AVIF. So I can come out here and see this thing is cool, it's smaller, it makes smaller photos than JPEG, that's true, but the browser support is so low that I would have to create a technique using, say, Picture, where I can actually say, if you're on this type of device and you understand this, please use it. Today, that's not worth it for me personally. So be aware these formats are out there. Can I Use just lets me come out and break down a given HTML or CSS3 feature and see how well it's supported across browsers. So again, I'm not going to use that yet. The other thing is responsive images. So our site has to work well on phones, tablets, and desktops for different design breakpoints. So when we first did responsive years ago, there was just the image tag, and that was it. And so we had to pick an image size. So what people did when responsive first came out, they typically served the image that was the largest one they had because it had to look good on the desktop. Well, the bad news was all the mobile users on potentially poor connections were getting really large images that they couldn't even display. So that's where they came up, the browser vendors came up with source set and picture. So on my image tag, ignore the data dash here for a moment, there's a source set attribute. I create the image in various widths. So you can see the widths that I chose. There's a lot of research into what you want for width sizes. You can look into some of that stuff. For this, I just did simple 128, 256, 512, etc. I embed the width name into my images just so I can see what's actually being downloaded in my log files. But by specifying source set, I'm leaving it up to the browser to look at the connection speed and everything else and decide which image to download. So that's another technique you'll want to look at, because if I were to show you the after version here and the sizes again, you can see that 128 is only 2K. The 2048 is 187K. So if you're on a device with a bad connection, or you're on a phone and you only need a small image, that's a drastically huge difference by using responsive and using source set and getting the right image for the right device. So back to JPEG. Why do I like JPEG? Because I can trade off size and quality. I can often cut the size by 50% or more without any visual impact. So if I show you, every time I say that to my designers, they kind of freak out because designers want the best quality. So I make a deal with them. I say, here's a set of images. I made the original and I've done some compression. And if you can pick out the original from here, I'll use it. But I bet you can't tell. And so I threw in a few that were obviously pretty crappy, right? These are way too small and you can tell. But if you look at the rest of these, it's pretty hard to pick out the original from the ones that I've tweaked to save size. It turns out the original is here. It's about 172K. And here's the version I actually use in production, which is about 32K. So again, visually, my customers are never going to notice the slight differences here in quality. I can do this in Photoshop. I happen to use PaintShop Pro. All I need to do is go, and usually the tool will show the original and the compressed, and I can just drag a slider and see where I think that trade-off is, where the quality starts to get poor, and then I get right before that. So it looks visually the same, but it's a lot smaller. Another thing to know with JPEG is there is a thing called progressive JPEG, so I need to turn something on in Fiddler. I'm going to make my site intentionally slow, which seems odd in a performance talk, but it'll make sense in a moment. I'm going to load two images here. One's a normal JPEG and one's what's called a progressive. So if you notice on a slow connection, this is what most all of us use for JPEGs. It's called a baseline. And the left side is a progressive. So if I show you that again, what a progressive does is it gets the shell of the entire image and then slowly brings the quality up compared to paint line by line. It's a huge perception difference, and perception is reality, right? So my customers, if I had a site full of images that use progressive and they have a slow connection, it's going to seem like it's loading so much faster than what you see on the right. Looks like it's horribly slow. So progressive, all I need to do, and I'm going to go change my Fiddler back so I don't forget. All I need to do when I save my images in PaintShop Pro and tools like that, I can specify progressive. So that's something you might want to look into. It was hot back in the modem days. I've been doing web development for a really long time. Now that we have a lot of mobile devices, it's something that you could take advantage of now. The last thing I'll mention about images is there is metadata in images. So I'm going to turn on another tool here. This is an extra download in Fiddler, and it's called Show Image Bloat. And if I go back, I will show you what this looks like. I'm going to hit Control F5. If you notice these bricks, what that's telling me is 15% of this image is actually metadata. So when I take pictures on my phone or on a camera, part of the images or part of the details inside that JPEG file is the shutter speed, the camera I used. None of my customers care about that, right? They don't want to have my file be 15% bigger just so that's in there because it doesn't visually impact anything. So I use a tool called Jpeg Tran. It will actually strip out that metadata. So if you've got lat long or any of your camera information, you can have that taken out. Again, it's just a performance enhancement that doesn't change the visual quality of your images. Next, we'll talk about image lazy loading. So if I've got a web page, I've got content above the fold, so to speak. So let's look at our after version here again. I've got stuff up here, but if I roll down, you'll see these images. Maybe the person won't scroll down at all. So why do I make them wait for the first paint of the page? I want to lazy load that. There is native support. It just came out within the last probably 6 months or a year in Chrome and others. If you go to Can I Use, it's still not everywhere yet. So I still use this plugin in production. I've used this for years. There's lots of different JavaScript plugins for this, but if we go back to the source code, that's what this data dash is. So instead of using source set, I use data dash source set and tell it that I want it lazy loaded. I include that JavaScript file down here. So what will happen again is when you come to the page, it's going to download all the images on the top. As I scroll down, that plugin will notice that I'm about to start seeing images and it'll tell the browser to download it in the background. So now I get, again, the best of both. The paint is really fast and I'm only making people download this stuff. So I'm saving them data on their data plan and I'm making it faster for them and less usage for me if they don't actually scroll down. So that's a great technique to use. This is one I've written personally and I call it Deferred Loading. There happen to be on our website, we use a lot of third-party tools, beacons, analytics, things that I need the page to run, but I don't want them to slow down the initial paint. So I actually created my own, it's called data-deferred source. So let's look at what that looks like. At the very top of this is the code, and all it does is it says, wait for the page to finish loading. So by that point, we'll have the initial paint done. And once that's done, I want to run this code. So it's just looking for any data-deferred sources. And if it sees it, it copies it to source. And if it sees source set, it copies it to there. So if you see, I've got some files here like this third-party script. All I need to do is say, please use data-deferred source. So what will happen is everything else that's important for the paint will run first. Once the onload is done, it'll come in the background, go get this file. So it's not like lazy loading. It's not waiting until I scroll. It's just moving when it asks for this file. So we've offloaded most of our vendor scripts and such to be deferred. That way our paint is a lot faster, and yet they still all get the stuff in the long run. They just get it later in the process. Speaking of loading resources, we'll talk about there have been some additions to JavaScript in the last few years that make loading better. So another thing I like about Fiddler, I can make individual requests slow. So I can target and see what kind of an impact that has on my performance. You can see I have 3 JavaScript files, and I've got my content on my page. In Fiddler and Autoresponder, I set up rules to say if you're looking for an alert, slow it down by 4 seconds. Alert 2 is 2 seconds, and alert 3 is 3 seconds. So the important thing, if you go watch what happens when I run this page, you don't see any content. So my customer is now waiting for these JavaScript files. So I'm just showing you the order they're running. So unfortunately, a delay, especially in a third-party JavaScript file that I might not have control on a vendor site, could make it where my page is not painting. And that's really unfortunate. If it turns out that these files are not needed for rendering, I can add async onto them. And what I'm telling the browser is, I want you to download that in the background. And as soon as you get it downloaded, go ahead and run it. So if we go run this again, I'm going to hit Control F5. You'll notice it painted right away. So my customer's experience, they get the page render immediately. And yet now you can see these fire. But if you notice, it fires in the order 2, 3, 1 because of how I did delays. That might be fine, right? If these aren't dependent on each other. If they are dependent on each other, I can use defer instead. So it's doing the same thing. It's allowing me to paint right away because I don't need these files for rendering. So my customer sees content, but it's going to force them to run in the order 1, 2, 3. So if you have dependencies, like you have jQuery and other stuff, you can force the order by using. So either one of these, if your browser doesn't support it, it'll just behave the way it did before. If it does support it, and most modern browsers do, you'll get a better download experience. Another cool thing is resource hints. So resource hints let me tell the browser things ahead of time. So for instance, if I know I need this JavaScript file down here from ajaxmicrosoft.com, I can set up a pre-connect in the header and tell it, please connect. So the nice thing is, as soon as the browser hits this line, it's going to start creating a connection out to ajaxmicrosoft.com. So it'll do the handshake, it'll get the TLS and the HTTPS set up. By the time the browser gets down here and sees the jQuery file, it may already have its connection. So that's a big advantage. Another cool thing, I don't personally use this yet because I don't have this, but if you came to this page and you were very confident that the customer would go to this home page next, you can actually tell it to pre-render. What'll happen is it's going to prioritize this page first, get it all painted, but then in the background, it's going to go actually get the default page, all of its resources, and render it. So if the user actually clicked on a link that took them to that page, they wouldn't have to wait for a download. Hopefully it would just instantly paint. So I would love to be in the situation. I knew exactly where they were going to go next. I'm trading off, right? I'm making a bet. If I'm going to waste some of their bandwidth, but if they do go to that page, the performance is going to be exceptional. So if that works for you, that's great. A couple miscellaneous things. Focus on your critical rendering path. So CSS, while I'm waiting for that to download, is going to stop my rendering from happening. So I'm now looking at whether I should inline my critical CSS. So for instance, I might split my CSS up into the important stuff that I need just to get the basic paint to work. I can then inline that CSS directly into my HTML, so my page doesn't have to wait for that CSS to download. It can start to paint immediately. So just focus on your critical rendering path. Defer things that don't need to run right away will give you the best performance. Another note, people forget that URLs are case sensitive. So if I look at this file, I've got the same exact flagbridge.jpg 4 times. I've got 3 different cases though. You can see capital F, capital B, just capital F. What'll happen with this, I'm going to clear out my requests. If I were to request that page, even though it's the exact same image, we'll see that it got downloaded. I'm going to turn off that image bloat. Sorry, it'll be a little more visible if we do that again. So even though it's the exact same image, that thing had to get downloaded 3 times. That's because browsers feel URL casing matters. So they assume these are 3 different images. So we just made the rule on our e-commerce site. We reference all of our resources lowercase, because what would happen otherwise is maybe I would use logo.svg with a capital L. I did everything we talked about. I compressed it. I set it up in your browser cache for the next year. My other developer uses all lowercase, comes to a page, even though it's sitting right in your browser cache, it's not going to use it. It's going to come back and re-download the same thing, which is horrible, right? So we just make the rule. We want all of our stuff to be lowercase so that that doesn't happen. Talked about HTTP2. I've got full hour talks on this, so we obviously don't have an hour. The important part about HTTP2, I talked about how in the past, HTTP 1.1 let you have 6 connections per host. The bad news with that is every connection you have to set up takes a while. There's a handshake, it's got to set up HTTPS. It does what's called slow start, so right away it assumes it's a slow connection and just gets better as it goes. HTTP2 says we're going to throw all that out and use one single connection to connect. So if I go show you what that looks like, actually I got to close Fiddler because it does not support HTTP2 right now. I'm going to show you, I kind of hate this demo and I kind of like it. Here's a web page that uses just HTTP and HTTP 1.1. If I hit the same thing using HTTPS, you saw how much faster. It was 82% faster, and that's kind of a head scratcher. HTTPS with encryption should be slower. The reason it's faster is because it uses HTTP2. You can't use HTTP2 without having HTTPS, which you want anyways. But because it's got a single connection, it doesn't have to do 6 at a time. You can see it paints a lot faster. So the reason I don't love this demo, I don't have a web page with 360 little check marks on it. But it's meant to be representative of, I do have pages that have maybe 75 requests, maybe 50 from my CDN. Being able to send those all over one connection is a big speed improvement. Now that I have HTTP2, I talked at the beginning that I have used techniques solely to reduce the number of HTTP requests. I talked about how I bundle all my JavaScript and CSS files. So I took all of my CSS, maybe 15 of them or whatever. I bundle them into a single CSS file in the past because that avoided that 6 connection limit. I could get all of my CSS in one shot. Now that HTTP2 doesn't penalize me for having the multiple requests, I'm not going to do things solely to get rid of the number of requests. So if you've done these kinds of techniques before, another thing people used to do in the past, if you had cdn.example.com, they'd create a CDN1 and a CDN2, then they'd have 18 total connections. Well, you don't need to do that anymore. So if you're doing any of these things, reconsider, test. If you're using HTTP2, you probably don't want to do them anymore. Some quick tools to help you evaluate your performance. I'm going to go back to my performance before. I'll actually pull it up locally. If you go into Dev Tools, there's a feature called Lighthouse. If you turn on performance, I'm going to run a report. I like this. It's going to give me a score. So it evaluates all the sorts of things we talked about in this talk and gives me a score for how well I comply. So I keep track of this for my site before and after. And you can see that my before version was about a 53. If I go run this same thing for my after version, let's generate that report again. We'll see how the performance improvement's done. Sweet. It was 100 the other day, so I lost something. But so I'm at 99 compared to 53. What's cool about it is it tells me down below, there's not as many to look at here, but if we looked at the before, it'll tell me like I'm not minifying my files, I'm not compressing my images. So everything we talked about today, they have nice links to explain why you want to do those things, how they work, and what you need to work on for your site. So that's very handy. Some quick resources. I'm a Pluralsight author. I have a full course on web performance where you can see how do I exactly do compression of images, how do you turn on compression, how do you do expirations. Same thing with the images here. How do I do progressive, things like that. My most recent, I have a debugging your website with Fiddler and Chrome DevTools. So if something's not working on your site, it walks you through how to solve it and which tool is more appropriate. And then I have an advanced one on Fiddler as well. So that's my Twitter, my email, my blog. there's a link to the slides and the code. And again, the code, I have both the before and after version for you.